All right, so this problem says an evacuated tube uses an accelerating voltage of 40 kilovolts, 40,000 volts to accelerate electrons to hit a copper plate that produces X-rays, non-relativistically. Non-relativistically, what would be the maximum speed of these electrons? Okay, so essentially here's an X-ray machine. So when you go to a doctor's office, those X-ray machines have 25, 30,000, 40,000 volts in them. Okay, so essentially what you're doing is, so here's the negative terminal, here's, okay, and this is, so here's what the problem is saying. Here's 40,000 volts. This spits out electrons, and the electrons accelerate toward the positive terminal. They hit a copper plate, and when they're stopped, all that kinetic energy is radiated as X-rays. Okay, so roughly that's the process. All right, what would be the maximum speed of these electrons? So you saw that, so the electrons are accelerating that way. The change in potential energy of the electrons is the charge of the electrons times the potential through which they dropped, and that gets converted to kinetic energy. Okay. So the potential energy they lost will get converted to kinetic energy, and I'm just writing magnitudes here. Okay. So if you want. All right, so the charge of the electron is E. They fall through that potential, and that's equal to 1/2 mv squared. So the speed of the electrons is 2e, the potential through which they fall, divided by their mass to the power half. All right, now let's put in numbers. The charge of the electron is 1.6 times 10 to the minus 19 coulomb. They fall through 40,000 volts. And the mass of the electron is 9.11 into 10 minus 31 kgs. Okay, let's take care of powers of 10 first. This comes up, that will become 10 to the power 12. And then I'll take 4 more from here. That's 10 to the 16 to the power half is 10 to the 8. Okay, now we're doing this non-relativistically. What that means is there is the non-relativistic formula. When you study relativity, you'll see that that has to be modified, but anyway. And what's left is 2 times 1.6 times 4 divided by 9.11 to the power half. Okay, so the speed of the electrons is 1.2 times 10 to the 8 meters per second. The speed of light is 3 times 10 to the 8 meters per second. Okay, so this is roughly 30% the speed of light. And generally you use this non-relativistic formula if you're within 10% the speed of light. So we really should not be using this, but for government work this is good. Okay. So these electrons in that X-ray machine, they're traveling at 30% the speed of light before they're stopped by this copper plate, and they emit their energy as electromagnetic radiation, which is X-rays. Okay. So that's how you produce these X-rays.